So let's talk about writing linear equations, and our learning targets will be to write a mathematical equation from a sentence and to be able to solve the value that satisfies the situation. So we're going to try to set up equations that we can eventually solve. A very important part of this is the let statement, our vocabulary word for today, which is to assign a variable an unknown value needed in order to solve a problem. A lot of students kind of skip over this and say, oh, I don't need this. This is just an unnecessary step. It's actually a very important step because it allows us to talk about something we may not have already had available to us in the problem. Okay? So let's take a look at the notes. I'll stop shouting to make the volume all the same. I'm like that used car salesman right now. I apologize. Shouting out at you. But here's the important part. The let statement says to let x represent a number. So we're going to use x for all of these. Kind of boring, and we're only going to do expressions to get things going here, okay? I'm going to start it off kind of easy and then build your confidence, and then we'll get to the more difficult things. So the first one says 1/2 of the number increased by 10. I'm always going to encourage students to underline important parts. 1/2 of the number increased by 10. This will become very important later on when these become a little bit more difficult. Now, one thing you could do on top of underlining is annotating. So going back up to the question and writing down little symbols like 1/2 and the variable x, which stands for the number, and then increase by was on our chart as addition. For the numbers that are already written, maybe you just kind of put it in bold, okay? So from here, you write down what you see if it's in the correct order, and this one is 1/2 x plus 10, okay? Pretty straightforward. Now you could also write this, and I just want to show you this because this is going to be the way we do this, as half a number, right? Half a number is the number divided by 2 plus 10. Both of these are correct answers, but just understand there's two ways to write this, and this way is going to be easier when it comes time to solve equations, okay? Moving on to the next one. 5 less than a number. 5 less than a number. Pretty straightforward. 5 minus x. But be careful here. How you write it or annotate it is not the answer, because this has to be written as x minus 5. You have to take 5 away from the number and not the number away from 5. So be very careful with how you answer this question, especially with less than. All right, next one. 5 times the sum of a number and 7. So there it is underlined. I'm going to go underneath and annotate. 5 multiply the sum, the number is x, and 7. Now this happens quite a bit. We will see two operations next to each other, and that's kind of weird because how are we going to write that down if they're right side by side? Well, and doesn't mean one specific operation. It could mean a couple of things. It just depends on how the question is written. In this case, and means we're adding the x and the 7. Okay? So we would write this out as 5 times the sum of x plus 7. And this still isn't fully finished because I'm not multiplying 5 times the sum. I'm multiplying 5 times x. And that's not what this question is asking for. So on my own, without them being said, I need to remember parentheses, because parentheses tell us to do that first, which is to add, then multiply. So that's 5 times the sum of x plus 7. Last one on this page, the difference between twice a number and 11. So reading it once is great. Coming back through and underlining the important parts that you read, also important. Then annotating. Whenever students are having difficulty with this in class, I go to this method and all I do is underline and annotate, and then they get the rest. They actually do all the work. I just kind of set them up. Difference was in the subtraction category. Twice was 2 times, and the number was x and 11. Okay? And so we were talking about the difference between twice a number and 11. Well, the and this time it means subtraction. Okay, so that was way out in front, but that's what we're actually trying to subtract. Twice a number, so 2x, and then minus 11. This one does not need parentheses because you're doing twice the number, not twice the difference, but twice whatever x is. Okay, so let me know if you have any questions. And if not, we'll keep moving on. So with the next one, we're going to write equations. And just to make sure we're still there, we're going to let x represent the number. So let statement already done for you. You didn't have to worry about it. Let's go through these and do the same thing. And now that they're a little bit more complex, underlining and annotating that much more important. A number that is just a setup. So don't think of this as a variable. It's just getting us going as to what we're talking about. But here's where it gets important. 3 more than twice the value of x is equal to, wonder what that means, 2 less than 1/4 of x. All right, there it is underlined. Always good to go back and annotate. 3 plus twice the value, there's our variable, is equal to is our equal sign, 2 less than 1/4 x. Okay, so there's our annotations. Now it's up to us to write a final product because the annotations doesn't always give us the answer. Over here on the left side, this is good. 3 more than twice x can be just left like that. I could have wrote 2x plus 3 and used the commutative property. Not really necessary. But over here, 2 less than 1/4 of x has to be switched. First of all, this has to be x divided by 4. 1/4 of something is dividing it by 4, and then minus 2. If you don't change the order, or if you don't make the 2 a negative, that's going to be an incorrect answer. Okay? Moving on to the next one. 7 less than 4 times the difference of x and 5 is the same as 3 times the sum of x and 10. Okay, so now let's go ahead and annotate. 7 less than a subtraction. 4, I'm going to use a dot for multiplication because I don't want to put a variable out there like an x. Difference is subtraction. X and 5 is the same as your equal sign, and then 3 times the sum, x, 10. Now, there's a couple instances here where I've got operations kind of right next to each other, so that can be a little tricky. The key thing is we can separate the left side from the right side because whatever's on the left isn't going to be affected by what's on the right. So here we go. 7 less than 4 times the difference of x and 5. Whenever we see this less than, probably kind of hold off on that. 4 times the difference is going to be 4 times x minus 5. But again, if I'm going to multiply that whole subtraction problem by 4, I need to put it in parentheses. 4 times the difference, 4 times the subtraction problem. Now I can come back and do less 7, so minus 7. And that's it. Left side is done. Over here, it's 3 times the sum of x and 10. So 3 times the sum, so adding x and 10. But again, what do I need? So without parentheses, we're doing 3 times the number. With the parentheses, we're doing 3 times the sum. So just key on those words. All right, last equation we're going to talk about. The ratio, that means a fraction, right? Division, of 3 less than x, okay, 2 more than x is equivalent, new word there maybe, 1/2 the sum of x and 4. Oh boy, a lot going on here. So let's pay attention and be careful. A ratio is a fraction. So I'm going to kind of do a little dashed line here for that. 3 is 3. Less than is one of those tricky subtraction ones, x. Now 2 is another way to write a ratio. So I'm going to write kind of like a colon there, right? There's lots of ways to write a ratio, a colon, a fraction, or using the word 2. 2 more than is addition, x. Equivalent is our equal sign, and then it's 1/2 the sum of x and 4. So there it is, fully annotated, okay? And it kind of looks like a lot, but if you focus on just 1/2 of the problem, it's not going to be so bad. So I'm going to go to a different color because this is all kind of blending in. A ratio is a fraction, so a top and a bottom. And the first thing they tell us is 3 less than x. So I'm going to put x minus 3. 3 less than x. I apologize for how small this is. And then it's going to be 2 more than x. So 2 plus x is how we would write that out. other side. So if we have 1/2 of the sum of x and 4, remember that half of something is dividing it by 2. So I'm going to go with another color here. I'm going to divide by 2. Now what am I going to divide? The sum of x plus 4. Okay? So if I write it as a fraction, I don't even need the parentheses. I can simply write it at x plus 4 divided by 2. All right? So there's just kind of the setup for this. The Miller family is mathematical. They're scientists, I guess. They're just like having some fun. They made mathematical statements for their ages, and here's what they've got. They've got Tom, all right, is 4 less than twice Gary's age. They got Rebecca. She's the youngest, but not worth underlining that. Just kind of remember that. She is 2 less than half Gary's age after it was increased by 3. And then we got Sam's age. She's a ratio 7 more than Gary's age to 8 less than Gary's age. And there's one very key thing here. Everybody is in relationship to Gary. So here's where we need to make sure we have a let statement. And that let statement is already given to you to let Gary's age be G. Okay? That's why those let statements are so important. Let's go through these and write 3 expressions, 1 for each family member. We'll start with Tom. Tom's pretty simple. 4 less than twice Gary's age. So Gary's age, which is 2 times Gary's age, twice Gary's age, then less 4, so 2G minus 4. Next up is Rebecca. She was kind of all over the place here. She's 2 less than half Gary's age after it was increased by 3. So careful here. Half of Gary's age, all right, so half a G, but it's got to be increased by 3 first. In order to do the adding first, I'd have to use parentheses, and then I'm going to lessen it by 2. All right. And then finally, Sam's age. Well, Sam is a ratio. So if she's a ratio, she's a fraction. And that fraction has a top and a bottom. And the top part is above the 2. All right, kind of like how this would be a colon here. So 7 more than Gary's age. Just know that we can put Gary's age first when we're using addition. So G plus 7, commutative property says that's fine. But 8 less than Gary's age has to be written as G minus 8 because if you subtract, subtraction's not commutative. All right, so those are the expressions for the Miller family. Now let's see if we can find out how old they are. What would we need to know? Obviously, Gary's age, right? So if we came up with Gary's age, we'd be able to substitute in his number for G. And they tell us that Gary is 11. All right, let's do twice 11 minus 4. And if this looks familiar, we've had this lesson before. We've done the order of operations. Everything that I teach you, hopefully you'll see again, and that's why we do it, so that you're good at it, so that you can be successful in it in the future. Next up is Rebecca's age. Tom's 18. Rebecca is, well, let's think about this, 11 plus 3. Then I can divide that by 2 and subtract 2. I just kind of changed this to our fraction look, and I substituted 11 in for G. Hopefully we're comfortable with that. So I'm going to add first, because that was obviously in parentheses. 14 divided by 2 minus 2. 14 divided by 2 is 7. And then 7 minus 2, we'd end up with 5. And I never want to put an equal sign in here because these are not equations. Very important that we stay away from using any type of equation. Last one, and we're done. Let's put 11 in for both of the G's. 11 plus 7 in the top, and then 11 minus 8 in the bottom. Go ahead, do the addition and the subtraction first. For 18 over 3. And 18 divided by 3 makes 6. And we do have one thing that we can do to fact check. Rebecca was the youngest. Is she the youngest? If Gary is 11 and Tom is 18 and Sam is 6, yep, 5 years old, she's the baby. She wins. Okay?